So let us configure only this part and revise few things. We'll configure the IP addresses. This network will be 192.168.1.0/24. This R1 will have 192.168.1.1. R2 will have 192.168.1.2. R3 will have 192.168.1.3. And R4 will have 192.168.1.4/24 is the network. So the total number of IP addresses within this network are how many? 256 total number, and valid are how many? 254, because we know that inside each and every network there are two reserved addresses, network ID and broadcast ID. So first we are configuring the IP address quickly. Now IP addresses are configured. We configure OSPF now. So R1, to configure rep we used to write router rep. To configure EIGRP, router EIGRP, and then the AS number. For OSPF we write router OSPF and then the process ID. And this process ID is a locally significant value. This is a locally significant value. This is not a neighborship condition in OSPF. So even if I'm running OSPF process ID 1 on R1 and OSPF process ID 2 on R2, that will not be a problem. They will still form neighborship. Well, actually the neighborship condition is what? That the area must match. We have discussed about neighborship conditions if you remember. The subnet mask must match, the area must match, the router ID must be unique. It must not be same, because router ID is the identity of a router within the OSPF domain. It cannot be same. And then we have hello and dead interval must match. If authentication is enabled, then authentication also must match. Authentication type also must match. Authentication type, we have three types of authentication: 0, 1 and 2. 0 means null authentication. Authentication is not there. 1 means plain text authentication, and 2 means MD5. Cryptographic authentication, we also call it cryptographic authentication, where the passwords are shared in an unreadable format. So here in OSPF we have to write this process ID. This process ID is a locally significant value. It does not have to match on routers for them to become neighbors. This is very similar to the process IDs which are taken on our devices also. Like on this device, there are so many applications which are running. Paint.net, GNS, right? We have got PDF files that are running. So all of these are different applications. Definitely all of these applications have been assigned different process IDs. This is the similar thing that happens in OSPF. So you give a process ID for OSPF process. So when we have taken this router OSPF process ID 1, now we will use the network command to enable the routing protocol on the interface. Now we know that OSPF is always classless, so we don't have to run this no auto summary command. There is no such command as no auto summary. No such command. It is always classless. We will directly enable routing protocol on the interface and we will put it inside area 0. So what we are writing is network command. With the help of network command, we are enabling OSPF on that interface which has IP address 12.1.1.1 exactly, because wildcard bits are 0000. This means exact IP address match, and then we are putting that interface inside area 0. So now when I enter this, the moment I enter this, now OSPF will get enabled on this interface. Now R1, अच्छा मेरे को 12 की इतनी आदत पड़ गई है, ये हर जगह 12 ही आता है. Okay, 192.168. You can also see this to show IP interface brief. On this particular interface F0 by 0, which has this 192.168.1.1 IP, we have enabled area 0. And we also know that the moment we enable OSPF on an interface, router starts transmitting OSPF hello messages every 10 seconds by default. So we can also capture it and see this. help of varchar we can capture what is the multicast address 224.0.0.5. This is a special multicast address 224.0.0. This means to all SPF routers, to all the OSPF running routers. So if you enable OSPF on any router, that router will automatically join this multicast address. And why do we multicast hello messages? Because we want to dynamically discover neighbors. We don't want to statically define all the neighbors. We want to dynamically discover neighbors with the help of multicasting. Multicasting means one to a group. And that group here is OSPF group. So automatically neighborship will be formed. And you can see that many things are getting shared within it. We'll be discussing about all the depths that what is this OSPF header and then what OSPF hello packet is. The 4-byte OSPF header is there. So all the details will be discussed once we reach our NP level. But right now we can see that version is what? 2. Now always remember OSPF came up with this first version which was version 1, OSPF version 1, but it did not practically got implemented. It remained in experimental stage. The version that came out properly and which was basically accepted widely everyone was version 2. So every time you will see version 2 only here. There is a slight exception if you talk about IPv6. Then in IPv6 there is OSPF version 3, not version 2. But for IPv4 there is OSPF version 2. Message type, we know there are multiple types of messages in OSPF. There is hello message, there is database description message, link state request message, link state update message, link state acknowledgement message. So this field basically tells which type of OSPF message is being carried within this packet. And then we have this packet length, the whole size of this packet. And then this is the router ID of that router which is transmitting this hello message. So the router ID of router R1 is 192.168.1.1. I would like to change few things here. What I will do is I will manually define router ID on each and every router. So let us go on R1's process, inside R1's process, and we will manually give R1 a router ID, and that is 1.1.1.1. I hope you remember how router ID is elected. First of all, it is seen whether the router ID has been configured manually. If the router ID has been configured manually, then that value is taken. If you have not manually configured router ID, then it is automatically elected on the basis of two parameters. Any highest IPv4 address on a non-shut loopback interface. And if loopback interface is not there, then highest IP4 address on non-shut non-loopback interface, any other interface. That priority and router ID is used for DR election process. For DR election. So I have manually changed the router ID now. And now we can see if I go to this new message, we will see now it is saying that my router ID is 1.1.1.1. And you can see that it belongs to which area? Backbone area. And you can also see check some values there for detecting errors within this OSPF packet. And then authentication type is 0, which means authentication is not enabled. And then the data is none because authentication is not there. And then we have the contents of the OSPF hello packets where subnet mask is getting shared. This has to match. Hello interval and dead interval is getting shared. This has to match. Then we have the priority value that is getting shared because we know that priority and router ID will be used for the DR election process. And always remember, if anybody asks you which message is used by OSPF for DR and BDR election process, you will tell them which message is used for that purpose. Hello message, because the hello message contains the priority value, the hello message contains the router ID, and both of these things are used for the election of DR and BDR. If anybody asks you which message is used to share brief information about the database description messages. If anybody asks you which message is used to carry the detailed information about the link state update messages. If anybody asks you how do you ask for detailed information about a particular link state request message. So if I want detailed information about a link, then I will send a link state request message for a link. That is how I will ask for the detailed information about a link. How do you acknowledge back for link state update messages? With the help of link state acknowledgement message. Each and every message has its own responsibility role in OSPF. So and we can see also DR information and the BDR information is also getting shared. Do you remember all of these things? Have we discussed about hello message and all the contents? And then we have few optional fields. These options fields basically tell the routers about the capabilities. So if I am running with OSPF, I will tell about my capabilities with the help of these options, these fields. We are not concerned with them right now, but when we'll reach NP level, we will try to understand few flags. These are all flags. We will try to understand few flags which are there inside it. So you can see all of these things. Once the DR BDR is selected, no other router can become the new DR. The reason is because whenever a new router will come, it will automatically get to know that this network already has a DR and BDR. Why? Because all the routers, when they send hello messages, they send the DR and BDR information. So if I am a new router, because of the hello messages, I will come to know that DR and BDR are already there and we don't have to elect a new DR, BDR. Right? If a DR is elected, then nobody can forcefully nobody can overthrow, nobody can forcefully become the DR, new DR. So when this is done, let us go to R2 now. Router OSPF2. कहीं पे भी doubts आए, if you have any doubts you can ask me there only. We are putting it inside area 0, but before putting it, what I will do is I will set the router ID manually. R2 will give router ID 2222, and then we will run the network command and put it inside area 0. And we will see that we will form neighborship. And now let us go to R3, router OSPF. Let us take process ID 3 here, and router ID will put manually this. And with the help of network command, we'll enable OSPF on its interface, put it inside area 0. Now R4 finally, router OSPF 4, router IDs 4444, network command to enable the routing protocol on the interface which has IP 192.168.1.4, putting it inside area 0. And now we will see that they have started to form. And now there is a strange thing that has happened. We will try to understand that strange thing. Tell me, according to you, who should become the DR here? R4. R4 should become the DR. But this has not happened. R1 has become the DR and R2 has become the BDR. Tell me the reason. Yes, perfect. Because R1 was configured first. And remember, whenever you enable OSPF on an interface, immediately a wait timer starts. So when you enable OSPF on an interface, that interface will not immediately elect DR BDR. It will not immediately elect DR BDR. It will wait for some time. And that wait timer is for 40 seconds. So suppose my interface got enabled with OSPF, I will not immediately let DR BDR, I will wait for 40 seconds so that I can give everyone equal opportunity to participate in the DR and BDR election process. So if I immediately come and immediately elect DR BDR, that will not be fair because I might elect myself as the DR. So I wait for some time, 40 seconds, I get their hello messages within that time, I note down their router ID and priority, each of the router which is there within the network, and once my timer is finished 40 seconds, then after that I elect what? DR and BDR. Are you getting the point? Once my timer is over, then I compare, okay, my router ID is this, that router's router ID is that other router's router ID is that. Let us compare and find who is the best one, and we will make the best router the route DR. Now I'll go to R4 and check this table which is called as the neighbor table. Now just like EIGRP maintains information about neighbors, similarly OSPF also maintains information about neighbors. Because we know that both EIGRP and OSPF form neighborships. So they keep information about neighbors. To see that, show IP OSPF neighbor, and then you can see that R4 says that one of my neighbor has router ID 1111, another router which is my neighbor has router ID 2222, and the third one is 3333. All of those neighbors have parity 1 on their interfaces. Who is the DR? DR is 1111. Who is the BDR? BDR is 2222. And the DR other router which could not become the DR or the BDR, they are named DR others. So R3 is DR other. Similarly, R4 is also a DR other, because within this network DR and BDR are already elected, and R3, R4 will become the DR other routers. And you can see one more thing, that with the DR, R4 has gone up to which state? Full state. That means they have shared link information totally with each other, and they have come to the full state. Full state means that whatever your database is, that same database is with me also. That means we will be making the same map of the topology because we have the same information. Similarly, R4 has also gone up to full state with the BDR, because we know that each and every router within a network not only forms adjacency with the DR, but also forms adjacency with the BDR. It shares link information but with both DR and the BDR. So with them, R4 has gone up to which state? Full state. But with the DR other, R4 has gone up to what? Two-way state. So R4 and R3 has not gone up to full state, and the reason is simple, because R4 and R3 does not have to be adjacent with each other. They don't have to be adjacent with each other. Reason is because they don't have to share link information directly with each other, because we know that within a network there is a systematic way of distributing link information, and all the routers form adjacency only with the DR and BDR. They don't share link information with each other. They just share the link information with the DR and the BDR. So because R4 and R3 both are DR other routers, so they don't have to share link information directly with each other. So they did not go to which state? Start state. Did not go to start state. They remained till two-way state. Two-way state means what? There is bidirectional visibility. I know about you. You know about me. Both of us know about each other. But we are not going to the start state, because we don't have to elect master and slave between us. We don't have to decide the sequence number, because we are not supposed to share link information directly with each other. Are you getting the whole point? So this is the reason they have gone only up to two-way state. Bidirectional visibility is there. Both of them know about each other, but they are not sharing link information. So they don't have to go to start, exchange, loading, and full states. They will not share data share करेंगे, normal packet share करेंगे, but they will not be sharing the topology information directly with each other in OSPF. Will share packets directly with each other. So now when this is done, we know what dead time is. Dead time is by default set to how many seconds? 40 seconds. If for 40 seconds my neighbor is silent, then I will break neighborship with that neighbor. You can see it starts from 39, 38, 37, 36, 35, 34, 33, 32, 31, 30, and then it goes back to 39. So what is happening is every 10 seconds the neighbor is sending hello messages, and this dead timer is getting refreshed. And then the address is there. Well, this value that you see right here is the router ID of the router with which I am neighbors with. But this address field tells the exact interface IP address with which I am neighbors. So R4 says that I am neighbors with a router which has router ID 11112222 and 3333, but the exact interface with which I am neighbors is 192.168.1.1, 192.168.1.2, 192.168.1.3. So this is what is written here, address field, exact interface IP address with which we are neighbors with. And then the interface to which R4 has discovered these neighbors. So R4 has discovered all of these neighbors via F0 by 0 interface, because R4 has received R1's hello message, R2's hello message, R3's hello message on which interface? F0 by 0 interface. So via that interface, those neighbors have been discovered. So this is how this neighbor table looks like. You can also change the priority value. It is very simple to change it. You directly go inside the interface, because we know that priority is associated with the interface. You can write IP OSPF priority that I want to set on this interface is whatever you want. Priority we know is an 8-bit value. So 256 possibilities from 0 to 255. And if you set priority 0 on an interface, then that interface does not participate in the DRN DDR election process. We discussed about this last time. Higher priorities preferred. You can change the priority on the interfaces. Now when this is done, let us go to a Wireshark. Let us see a capture here. 192.168.1.1 is multicasting a hello message. You can see here. It is multicasting a hello message. 192.168.1.1 R1. And then you can see that R1 is telling inside the hello message, its hello message, that my neighbors are those routers with router ID 2222, 3333 and 4. This is how they achieve two-way visibility, bidirectional visibility. Active neighbors, active neighbor field. When this is done, you can also see this thing at home. Do one thing, go to R1, you will do this lab, you will try to understand how things are occurring. You shut down the interface, and then again you no shut down it, and you will be able to capture all the things, all the events that will occur, because we already have this Wireshark running. So now we will be able to capture all the events that will occur between these routers. So these are the different events that are occurring between them. And you can see here that 192.168.1.1 is talking to 1.2, is talking to 1.4, it is talking to them, and that is how they are sharing all the information. So initially, with the help of database description message, master and slave election took place. We'll not get into the details right now because it is NP level, but there is one bit, there is one flag which basically tells that, okay, who is the master? I am the master. I told you about this, I think. When we talked about poll and response process, initially what is elected? Master and slave. So initially, both the routers will say that I am the master. And that guy will be elected who has the highest router ID. And then the sequence number that the master decides will be followed by the slave also. So you can see that master said that I am the master, and we will start with sequence number 9955. And then the reply came that, okay, you are the master, I am not the master. But initially, let's see here. Initially, what was 1.1 saying to 1.2? That I am the master, and we'll start with 4371. But when 1.2 replied back to 1.1, 1.2 told that no, I am the master. We will start with 9955. And then 1.1 said, okay, you are the master, I am not the master, and we will follow what you say. We will go with your sequence number 9955. And this is how they have started to briefly describe their database. They have entered the exchange state. We will see all of these things properly when we reach our NP level.